Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 2nd, 2025, about 5 days ago. It introduces a detector called ECLIPSE that cuts hallucination rates in a financial question answering setting by 92% at 30% coverage, far surpassing a simple uncertainty-based baseline. The paper is titled, Detecting AI Hallucinations in Finance, an Information Theoretic Method Cuts Hallucination Rate by 92%. And as we will see later, the way ECLIPSE uses token probabilities and evidence to flag confidently wrong answers is both clever and practically important. Alright, the previous description outlined what features ECLIPSE uses, and Table 2 now shows how strongly each feature contributes to predicting hallucinations. The largest positive weights go to the log probability with evidence and to raw entropy, which both increase the hallucination score. Strong negative weights on capacity lift and the ratio feature mean that better use of evidence lowers risk. The standout surprise is Pmax, whose positive weights suggest that very peaked token probabilities often signal confidently wrong, hallucinated answers. Well, Figure 2 turns those coefficient numbers into a visual ranking by absolute size, so the most influential features stand out immediately. The longest green bars correspond to the perplexity-based evidence features, especially the log probability with evidence and the ratio feature, which confirms that how the model uses retrieved context really drives detection. Shorter green bars for entropy, the log probability without evidence, and capacity play supporting roles. The single red bar for Pmax highlights the surprising result that very high token confidence actually increases predicted hallucination risk in this dataset. Alright, Figure 1 steps back from feature weights and compares full detectors using receiver operating characteristic curves. The solid blue ECLIPSE curve hugs the top left, delivering an area under the curve of about 0.89, which means strong discrimination between hallucinated and clean answers. The dashed orange entropy-only curve sits much lower, at roughly 0.68, and even trails methods like self-check GPT and semantic entropy probes. The gray diagonal random line shows what a useless detector would look like, highlighting how much ECLIPSE improves over chance. So while Figure 1 compared whole detectors, Figure 3 breaks down how each feature group boosts performance. The first light bar, using entropy only, reaches about 0.68 area under the curve, well below the dashed 0.89 line at the top. Adding capacity raises this to roughly 0.78, so evidence quantity clearly matters. Adding the basic perplexity features lifts performance again to about 0.84, and the full perplexity decomposition finally reaches 0.89, nearly doubling effectiveness over the entropy baseline. Okay, Figure 4 translates those gains into real deployment trade-offs between coverage and hallucination rate. The solid ECLIPSE curve stays well below the dashed entropy-only curve across all coverage levels, so accepting more answers always hurts less with ECLIPSE. At 30% coverage, ECLIPSE keeps hallucinations near 3%, while entropy only sits above 40%, giving that striking 92% relative reduction. Even at 90% coverage, ECLIPSE still maintains noticeably lower hallucination rates. So the big message is that hallucinations in finance hinge on a mismatch between model uncertainty and how well the retrieved evidence can actually support an answer, and ECLIPSE quantifies that gap very effectively. More broadly, it shows that token-level probabilities are not just plumbing, they are powerful safety signals. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.